Alright, well let's sort of get underway. So I won't talk too much. Welcome everyone. So we've got Andreas talking today. So Andreas was speaking at SQL Saturday down in Melbourne and in Sydney. I'll let him talk a little bit about himself if he so chooses to. So I've known Andreas for a little bit of a while. So he's an MVP, he's based in Germany. And he knows stuff about SQL. So he's going to be talking about locking concurrency inside SQL Server. And as I said, I'll let you talk about it.
Alright, yeah. Thank you for joining me for this session on locks, locking concurrency in SQL Server. And yeah, a bit about myself. I worked with SQL Server since about 18 years. Always easy to remember since the year and version 2000 almost. 7.0, who cares? And since then I've done work in data warehousing, OLTP design, data warehouse design, and of course performance analysis, tuning, and high availability. Also security is a special topic that I like a lot. Yeah, I'm still based in Germany, not for long though, you will see. One of the Microsoft Certified Masters in the world, I guess. Yeah, that should be sufficient. My company is Sarpedon, so I do work not only in Europe but also in Asia lately. Yeah. Okay. Now, how about you? In order to know you a little bit better, I would like to know who would be a developer who writes code in SQL. Alright. Okay, application developer, like the front end design stuff. Nobody really? Okay. Administrators, the same people and some more. Okay. Alright. Now, SQL Server version doesn't really matter for this talk a lot. The things have not changed substantially, except, of course, In-Memory OLTP doesn't exist before 2014. But the locking and blocking behavior itself is not really changed. Not really, I'm saying a little bit carefully, because yes, under the hood, some things do change, but on a level that's not documented even, it's just a little bit different behavior, and that you will only see when you run scripts and really monitor carefully with DMVs. You will see, oh, in 2016 this happened first, and now it's happening this way, sometimes, but it should not matter for practical usage. So I will have a script that I'm actually curious about how it will behave in this release of SQL Server with CQ4 or something. I'm expecting it to behave differently than I used to before. Happens. Anyway, what really matters is the end result usually, not the time in between. You will know that. Okie dokie. Yeah, but anyways, for my curiosity, who is on 2016 production? Okay, 2017, anybody yet already? One person. And who is still below 2008? What? Below 2000? No. Okay, well, it exists. Every once in a while you get a raise hands there. Okay. So this is basically my agenda. Some theory about blocking, and a little bit demos here and there, some stuff on Lock-Escalation and how you can avoid locks, how you can circumvent the blocking, and yeah, of course the infamous 1205, the deadlock, and a little bit about snapshot isolation and In-Memory OLTP. Okay, so why do we have locking at all? I mean, it's very annoying, it takes time. It's one of the things that if you do performance analysis, that can be the reason. The cause for poor performance is blocking situation. So without the lock, obviously, might be better. So there's a reason, and the reason is in the I of ACID, the isolation of transactions, or to be accurate, of the data that is being handled inside transactions has to be isolated, depending on the concurrency level, from processes running at the same time. So it's basically a logical layer that exists in transaction, and to make sure that you are isolated, you can use locking. Alright. Now, let me actually start with this one here, with this slide. What I mean by isolation levels, I suppose you all know that we're using, which one is it before here? This one. And if you look just high level, you might be a little bit surprised by looking, by seeing, well, it's not so green after all, right? Some people would expect, read committed should be a very, very safe one. Green sounds safe, red not so much. Because those colors up here are the phenomena that can occur in a relational database system. So they can occur. Now the question is, we don't want them to occur, and that's where you have those different isolation levels. So under the isolation level read committed, it is allowed that lost updates can happen, but it's not allowed that virtual reads can happen, and so on. That is how you read this stuff. So, anybody already familiar with all this stuff? So I don't want to bore you. Quick results up. Before I guess it's interesting for the others, hopefully. So we committed everybody broadly knows it must be very bad. Yes, the slide says everything is red. It is indeed so. Everything can happen on this level. The so-called data-read and unique data that has not really been committed, but it's all on a logical level. This is something important to remember, which also differentiates locking from ledging. So you cannot read corrupt data in a way. But this cannot happen. This has nothing to do with locking. Ledging is the physical protection, locking is for the logical protection. And yeah, so we committed, it's not so safe after all. So we see a difference here towards between repeatable read and recommitted. In repeatable read, you can make sure that you don't have non-repeatable reads. Makes sense, right? Easy to remember, but also no lost updates. And still you have the phantom read. And now there's the hardest one, the serializable, that really prevents almost all of those, actually all of the phenomena, because the last column is not a phenomenon, it's more like a technique. It was included. So all phenomena are not allowed in serializable. Sometimes you will choose it if you want to make sure that nobody can even see data before it has been committed for the whole time of a transaction that's running somewhere in the background. Like the opposite and the versus read committed, for example. Anyone has an example for a non-repeatable read? Read committed? When would a non-repeatable read happen?
When you, for example, reread the same data beyond the same SQL, right? Then you can have that non-repeatable. Something which was committed previously when you run the first time, now will be committed, for example, the second time. So you will see different set of data. So when you run the same, you see different result sets.
Yeah, that's true. Because for the lifetime of a read-committed transaction, read-committed reading transaction, you don't block somebody who's working on the data, updating data.
This might be committed. When it's committed the second time.
Yeah, it has to be committed, otherwise it would be uncommitted. But even when the data has been changed twice during the runtime, during a transaction, you read twice on the same table. First time somebody worked on the table and committed, second time somebody else worked on the table and committed it also. You get different results. Total normal behavior, really no problem. But this explains the non-repeatability. And the serializable is completely preventing all of that. Basically, like behaving like one works after the another person on the data. Really putting a serial behind each other, the transactions. So I will hopefully have some examples of some of them. Let me just start with one basic example to warm up a little bit with locking and blocking. Now I do have a session here for analyzing the currently existing blocks. So right now there is no block blocking going on. Basically, I'm clearing the system XQ request which I'm joining, but the basic DME is the system client logs, where I get all logs that currently reside. Simply logs. If there are logs, okay, we will also see, but basically I see all logs. Now, if you have worked this done, this DME, you may wonder why I'm not seeing anything. Because usually we do see data, even if you're not really blocking, and this is because I simply excluded the data, the resource time of database. Because you always add a log on a database once you access the database. There's no way you cannot have a log there. So I ignore this one just to make the design a little bit clean, because this log type is not, this resource is not interesting. So all logs on the current database got logging demos, but not the one on the resource on the database itself. This is basically my watching session. Now, the real transaction is going to come and create a table and insert some row in the table. And just run an update on this table. So update is run, and you can see I actually do have a transaction open. Yeah, transaction is open. I can see my own inserted data. So from this transaction, I can see the data that I've just updated. I see the Bravo, even though the transaction is not committed. Yeah? So inside my own transaction, I can see the uncommitted data. Yeah. If I now take a look here, I will see the logs that the SQL Server engine needs to accomplish this. Just to make sure if somebody else stumbles upon this data, please have a look here. Basically, I currently have an exclusive log on the grid row identifier, and I have an intent log on the table at the page. So those logs are here. Nobody is being blocked right now, but the logs are there. Just for the case somebody comes. Alright. Now I'm just gonna roll it back so we stick with alpha. Now another kind of locking, that might be interesting is like what happens if you actually create, alter, rebuild index on the table. Let's also have a look at this one. Inside the transaction, create a clustered index, and let's now look a little bit more exhaustive. You can see there are many logs on sys objects, on system tables here. Intent exclusive. On the table itself, there's a schema, metadata block that you will see in the real world. Also, sometimes we do an index rebuild. We have some pages being blocked exclusively. And metadata is shared here, and the keys belonging to the data also exclusively locked. The arbitrary, the extent is being blocked, so everything that contains the data is now blocked, and it contains the index structure. Clustered index basically means the table is being converted into a clustered index, so there's not really anything left that's not locked. The table is super small. This is why I get away with just 2 pages here. Alright, that would be another example of a locking. Now let's commit this one. Clustered index is always nice. Now let's get back to normal user transactions and start with an update on this table and change the column to Charlie. Now we have seen this kind of blocking already. We know there will be a page, an object log, the intent, and the key. Now it's the key, not the read anymore. We had before, because before we had the heap. Now we have the clustered index, and for identifying data, there we have the key. So a little bit different, but basically do it the same. Now this is session 1, and I have a session 2 here, which is going to come and read the data from this table, and this is probably prone to fail, right? So I just read the current split here. This is why you get some data here, but you're still waiting, you're executing, nothing is returned from the table. This is a typical blocking situation. You're waiting, you use wait stats to see that. Or I look in my watcher session to see if it gets more interesting here. Now we remember those three were the first session, blocking, the locking session basically. And by looking at those rows, I can see indeed he is waiting. And now basically we are talking about that blocking situation. So if there's a block and somebody tries to get it, this is the block. So you can see the split here, the sort process ID 12, the 54 is the one that I'm using in the second one, and we also have the column head blocker here, which you can also see in the activity monitor if you happen to use this tool. You will see also here suspended, no, this is a different one, so it's this one here, blocked by 112. This is the one that's waiting, and somewhere, the 112, this one here, has the head blocker set. This is the only time I'm going to open this tool because I really hate it, so let's get rid of this one. Question?
It's well worth taking.
What?
It's well worth taking.
Yeah, it's well worth taking, so I hope you agree and don't take it personal if I don't show this tool anymore. Alright, so those are the most interesting columns here. Wait type we have here, the log MS, basically the shared log, because it just wants to read, and you probably have heard that there's a shared log for that. The command type, it's the select, the isolation level 2. Always good to know if you do troubleshooting, because maybe he is being blocked in circumstances that are not so obvious. And then maybe it's because a different transaction isolation that is being used. So number 1 would be, which one?
Read uncommit.
Read uncommit, yes. And number 3 will be repeated reads, actually it's increasing. But I don't know, the in-memory versions, I think they don't follow this number anymore. But the old style isolation level definitely up to serializable, it's number 4, 3. 3? Serializable 3?
Yeah, 0, 1, 2, 3.
No, this is 2. 2 is recommitted.
Oh, I'm talking about ANSI transaction isolation levels.
To be quiet like that. Okay. So if you see a 4 or a 3, you already should be paying attention here. Even if you see a 1, so something is not common, it can be an indicator for mistake, basically. Alright, so now we just have 2 sessions. Let's get on the right server. The demo I did here, or where did I do my demo? I got confused. Okay, it works more than also local, this one. No problem. So we have 2 sessions now, and the third one's going to come. The third session is also going to start a transaction and an update to Charlie, and then nothing else. So let's see. Obviously, it has to wait. It will be the split 99. Now the big question is, for which session is this session waiting? Okay. Now the 99 is the next one. And now you can see the 99 is asking for an exclusive block. That makes sense. I mean, the original update is doing the same. Also has an exclusive block, except it has been granted. Now this one is waiting. And it is waiting for this session 54, which is the select. Let's remember this ordering. The rest is basically the same. The same resource obviously makes all sense. Alright, session number 3, waiting for session number 2, waiting for session number 1. This is the order right now. And now we have a 4th session. This session is going to do just a select. Bang, it's session 55. And now my watcher session is here. Now the big question, and the answer I don't know yet, because the different CU might have changed. Let's see. Where will this one be waiting for? Now, it's in fact also waiting for 54. Okay, so this has not changed the behavior. And this could be, would be very interesting, actually. So it means they have not fixed this one. Interesting. I already complained about this years ago. That's not a big deal, but 4th session coming, and it's waiting for the session which is the number 2. happens to be this one is reading, this one is also reading, now wants to read basically. So they want to do the same thing, they have a shared one. Right, okay, I get that one. But why would this one wait for the second one and not for the third one? It's a bit risky if you think it's really. I mean, if I keep going now and I would add other sessions with select, 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 it looks like they would all pile up waiting for this one, right? So let's say we have 100 sessions jumping ahead of session 99, logically, waiting for 54, meaning session number 99 indeed would have to wait until all those are also done. Yeah? This would be log starvation. You may have heard the word, and it would be happening. But fortunately, it will not happen. At least not in the other builds. Let's see. I don't think it will happen. But it's a little bit confusing. Not really the way it should work. But this is just the state of right now. And nothing happened yet. They are all waiting. Let's see what happens if I actually get rid of the first lock. Right? Alright, the first lock is here. Let me just double check my notes in session number 4. Yeah. Alright. So now get me to session number 1. Session number 1 is here. And I will roll back the transaction. What is this number? No, it's not number 1. Sorry. Here, this one. So I'm not rolling back. I'm committing actually. Very nice of me, isn't it? Now you've seen the backbone, another session has finished. Now let's see the watcher session. So this is the state of before. So it was 112, 54, 99, 55. I ordered it in this order also. So let's see what's happening now. What happened? Has it resolved according to what we saw before? No, it changed. It just changed the order of things. Yeah. Now suddenly session 55 is actually waiting for 99 and not for 54, which is finished. If it would have done what was written there before, it should be gone out, right? Now session number 99, yeah, because 54 is done. Yeah, so it would either be ahead of 99 or actually should be done, yeah, because reading would not have to wait for anything anymore. Yeah? So this is one of the things where you can sometimes get confusing intermediate results. And you check. So as we saw, it kind of resolved without showing us exactly how, but it resolved the potential log starvation problem by keeping the original order of things in which order of time order the sessions came. This is an important concept to not make those exclusive logs wait indefinitely. If the selects will always jump ahead, that would be log starvation. So there is an inbuilt detection mechanism, which I unfortunately cannot show you itself, but I can just show you the result of it. Alright, does it make sense? Victor? Yes. Good. Okay. So let me just get rid of all the logs here. Because the last was just a select from the waveform. Okay, so this was a short introduction and demo how you can monitor logging with the Sarpedon logs and how it behaves. Yeah. So we saw basically a log chain, but also the behavior that we have conflict there. Alright, now this is back to the slide with the pictures. The picture slide of those phenomena, basically just writing what they are. So read prevented, obviously, and dirty read. Select cannot read until the first update is done. and the second update was running behind that. So the next update would have to wait for that one. That's what we have seen here.
Yeah, those are some other ways how you can look into locking. For that.
Okay, so basically locking is the concept of that readers do actually block writers. Can happen. It's just you don't see it so often because readers are hopefully quick enough that you don't see it, but they do. And writers obviously block readers. This is what you see mostly in the world. But both types can exist. So the readers block writers phenomena is very obvious if we have the repeatable read transaction isolation level. Nobody can write anything on this table as long as there is a reader somewhere in the range of the table. But it's in fact also the case if you have read committed. I mean, it reads through the data one by one, basically, and if for some reason you're trying to update a row where it is just trying to read, you would also have to wait until the reading is done. It's going to be done very quickly, and you will hopefully not really notice it. But it can happen, of course. Okay, now there is some logic behind what kind of blocking, what kind of lock is preventing another lock to occur on the scope. This is the complete graphic, which I'm not going to talk with you right now. It's a little bit too long. Just maybe you can remember those schema ones and range locks here. Those are some special ones that you see under maintenance, for example. And those here, those range locks, you only see when you are using cursors. Now, the abbreviated version of that one, and you get a slide by the way. Of course, you're welcome to take pictures by the slides that are uploaded someday, the next days. This is the abbreviated version of the lock compatibility matrix. I think you can find it online also. Just use a little bit more color here. So we have an existing session basically. An existing session has been granted some kind of lock type, and there is somebody else who wants to get to the data in a certain mode. This is how you read it. So we had the scenario that some session was updating data. We saw the X lock, not the update lock. It's a completely different purpose. We saw the X lock. The X lock is for exclusive lock. When you change data, update, insert, delete, all those three things need the exclusive lock. Now, the exclusive lock is very obviously not compatible with anybody. If there's an exclusive, we have to wait until the exclusive one is completely gone. But let's say we have a shared lock. The shared lock can happily coexist with another shared lock, for example. But it cannot coexist with an exclusive lock, obviously. It can also not coexist with an update lock. And here's a little bit interesting one, the intent exclusive. If you just look at the matrix, it might look, oh, what the heck, it's exclusive, sounds dangerous, so why is that all of a sudden now, like an island, compatible with another exclusive one? Anybody any idea what this intent exclusive is actually doing? If you know that, then you have to answer why it can happily coexist. So it's the naming is a little bit is not really helpful, let's say. So can confuse. The idea of the intent exclusive is basically to say that on which scopes did we see it? We'll take from there that side. Did we see the intent exclusive on the key, on the actual data row? No, right? It was on the higher levels, both of them. Right? It was on the page and on the object, right? So from that, you can derive the real reason or the cause for this, the intent for it is to have a pointer on object level to tell SQL Server engine very quickly watch out, somewhere below in the hierarchy, you will find an exclusive block, a pure exclusive block. Yeah, it's more like a pointer on object level, also on page level. Now you have hit the page, somewhere here is the dangerous exclusive block. Don't even try to go so far, you will be blocked in some point. Yeah? So it's more like a pointer for optimization of the engine. Yeah, because you have to imagine now you have hundreds of sessions who potentially want to go to the same table, and SQL Server needs an efficient way to find out, let's say we have 100 sessions and we have 3 guys changing data. So out of a table with 1 million rows, for example, there are 3 exclusively locked rows. Yeah, but SQL Server has hundreds of other sessions that need to read data. So, and there may be other objects, obviously. So in order to tell SQL Server quickly that he can expect a lock deeper down the road, this is where he has the exclusive lock. And you will obviously not have an exclusive lock on tables that are having no lock, so there he doesn't need to keep searching. Yeah, but you can look first, give me any object locks for readers for this table. And then, okay, we have an exclusive, we need to keep looking, maybe it's the same page range that we are trying to access. Yeah, so it's basically kind of index, maybe you can think of it for getting quickly finding out if my session that wants to read needs to pay attention because there will be a lock somewhere or not. Yeah? If the object already has an intent exclusive, then keep looking. If it doesn't, well, obviously there cannot be any exclusive lock, so you can read. Yeah. That's in rough the idea of the intent exclusive lock. Yeah. This is why it can coexist, because 2 people can write on different areas of the table. Still the same exclusive block on the table, but different keys will have an exclusive block.
Is it also used for escalation?
What?
But is it also used for Lock-Escalation?
It is definitely active when you have Lock-Escalation. Is it really being used by the engine? I don't think this is really necessary. But you will see it when you have Lock-Escalation. You also have intent exclusive, because Lock-Escalation happens when you have many exclusive. So you have intent exclusive, obviously. It may happen, let me think, but no, it's not now. It's only for X. Oh, let me take this back. I cannot think of a case, but in theory, if you would have like 5,000-6,000 intent exclusive or 5,000-6,000 pages, I-axis, not access, then they would also escalate. That's possible. But I cannot think of a scenario where this would actually happen, because if you have so many I-axes already on page level, you probably have tens of thousands exclusive on row level already. So I would not know a case where this would happen. I don't see it probably.
Are you talking about promotion or escalation?
He's asking about escalation.
Yeah.
You mean escalation? When you say escalation,
Yeah,
not promotion.
I think so.
Promotion is for election.
Okay. Yeah, any questions here? No. This is a list of what resource types can be locked, and there are some more subtypes, but those are the most common ones. Database I already filtered out. We saw object page and key or red. We also saw hot because of the change of the index. The rewrite of the whole index. The metadata we also saw extend in that moment. You could also have a file lock if you're working with file groups and you are doing something file level. Application, obviously. Application is something that I rarely ever see. Has anybody used application locks? It really is an interesting feature. Can do a lot of cool things with it. But it's totally underestimated, or not known, I don't know. So Victor raised his hand. So Victor, you write your code as application log, or you have seen it at customers? No, I send it to customers.
You have seen it, yeah. It's very rare. Application logs basically is something, as the name says, from the application, but not being the end application. It's something you can write in your own T-SQL, in your stored procedure. You can say, now start a log in the process procedure. not like put a lock on the table, but on a procedure level. For example, like I say, they have serialized access to make sure only one person at a time can enter this code block, basically the part of the procedure at one time, put everybody behind me. So kind of serialization that you can accomplish within your stored procedure, but by naming your own locked entity. You give your own name, another thing that you will see an application log on a procedure name, for example. It's different from serializable locking, which will go for the whole transaction. This one will only happen for a part that you say, let's say you are transferring data from one table to another and do some calculation. You only want this to happen once per user in a certain moment of time. Like you don't want that two people at the same time on the server are running the same process, even if they would work on different data. Yeah, that's the point. Transaction isolation will of course protect the data, but you want it to be logically disconnected. It's interesting. It is documented, but not very extensively. You will probably need a bit of time to get used to that. Alright, another thing that you can do to follow those blocking situation is using the block process report. Anybody has used that before? For analysis, only one? Anybody has heard of it before? Not really. That's interesting. Good. Now, this is a server option. Maybe you have stumbled over it. It's the default is 0, so it's turned off, basically, but you can change it. The default would be 30 seconds, and I would usually advise you to keep it there unless you really know what you're doing. So basically, it would mean after 30 seconds, or every 30 seconds actually, SQL Server, no, sorry, not every, so this is still wrong. No. SQL Server has its own locking monitor in the background. The monitor in the background goes, the lock monitor checks every X seconds. Which seconds? What's the 5 seconds, right. So this is the same one that detects deadlocks, for example, which is why deadlocks maximally take 5 seconds to be detected. Yeah? The resolution may take longer, but every 5 seconds it's checking is there a locking, a blocking situation, plus if it isn't even a deadlock situation. But with this block process report, you can enable SQL Server to also watch out to just blocking, not even deadlocks, just blocking situations which have happened for longer than 30 seconds. That's the setting, that's what it does. You can trim it down a little bit, like 20 seconds. I would not go deeper than 15 seconds. And after that you will get strange results because the deadlock monitor only goes every 5 seconds, so it would not behave the way you expect. Just leave it 15 seconds minimum, basically. Yeah, so then you have a event that happens, that's the block process report event. And this event, you can catch this event notifications, or with extended events, obviously. I hope you're not using anymore this old tool here. Yeah, there it is, which could not also, of course, see it. Alright. Yeah, I guess we can see that. Want to see a demo of that? Easily done, just need to wait 30 seconds, right? At least that's what the theory says. So, let me go on this server now. And yeah, why not have a extend event session there? Let me see if I have prepared this one now. Deadlock, Lock-Escalation, lock waits, deadlock, wait info, modifiers, deadlock. No, it's not there. So let's create a new event session. Why should I reuse this one? I will just change it. Alright, so we have a session locking here now with some other events included, but not the one that I'm talking about yet. So properties, let's just have a graphical view at this session. It has a name and it has events. Here are the events again. Now let me just check, we have the deadlock, we have the chain of the deadlock, we have escalation, we have the released event. We can filter, log waits,
waiting for. I just leave it like that. And we're going to put here is search for block, not click, block. For this called block process report, right? So you don't need to know the whole word as part of it. Block process event report, sorry, is the one you need. I'm going to take the configuration and I will try to configure this just as the others. So database name, sequence, session ID, oops, SQL text. Okay, and the filter, let's see how we have it here. Locking there was. I will not put a filter. I mean, there will be one block resource report on the server level, yeah, if I have this situation. I will not bother the filtering right now for this demo. Here we can see the event fields that are coming by default. So we see the mode of the lock, the object ID, not the name of the database, so we can find out which object is being locked. Data store, I have the ring buffer, which is ugly, so let's add the event file. Alright, that's big enough. And 1 second dispatch latency. It's good for demos, but don't do this live. It would be a bit brutal. Now, we have a session here waiting for data. Let's close this one here. Yeah. Okay, so watch live data. Now I'm sure there's already things happening, but the block process report needs to be configured. So right click on the server, advanced, and here we have the processor. Can you see this in the back? Okay. So I put here, I will put 15 seconds. Should also be fine. Now you can also see the script for that. It's just an SP configure option. That's it. Advanced options, threshold 15 seconds. Alright. So now basically, from now on the whole server, I will always get a special event if anything waits longer than 15 seconds for a lock to be granted, which is a block. Yeah? Block and lock. It's not exactly the same, but it's like it. So, and we know how to make a lock or a block. We have those sessions here lying around, just need to wait 15 seconds. So, back here. Create, oops. Create for a small table. Update table. And have a second session. Trying to read the data. Now I'm going to go to the send event session, and basically it will take 15 seconds now until we will see the block process report. All the other stuff you can ignore, and there are some other logs going on, but not the one you're interested in. There it is, block process report. Now, we have the block process. Here is the first column, and I can copy this field if I so fancy, open new window and paste it here, and edit, advanced, word wrap. Oh, what? Yeah, should be very long. Yeah, absolutely. So this is something that you may have seen similar. What does this remind you of? Deadlock graph, right? That's the same. It's just a lock graph, lock process graph. You just know it's not a deadlock, it's just something that took longer than 15 seconds. That's everything. Yeah? So it's basically the same style as for deadlock. You can interpret it in the same way. As you can see, this now keeps popping up every 5 seconds, should be 38. Not right.
Filter one. Follow it quickly and just filter this one out here. Filter and guideline. Block process deport. We have it at 43.53 at 44.8, not 15 seconds. 15 seconds later. Okay. Every 15 seconds popping up for the same. I mean, it takes longer than 15 seconds. It keeps popping up. So if you have a very long blocking situation, it's still the same. You have to make sure that you don't interpret it like, oh, there's many of them, or it's just the same. And you will have to find some value, transaction ID, for example, that this is indeed the same or something like that. So this is a way how you can analyze blocking problems or problems caused by blocking on your system. Now there is one big drawback to every method that you will have. To every method. If you have ever done troubleshooting for blocking, what is the big problem that you end up having a lot of times? Whatever you see here will be the result. I mean, it's going to notify you at 15 seconds. And even if it notifies you after 5 or 10 seconds, it can still happen that you will just see a select statement as the source statement, as the first session. And this is why, or this is because the original update may be followed by a select session, and now somebody gets blocked by the first session, which is still holding up its exclusive block, is already running a select statement, very boring statement, totally nothing to do with the first update statement, but the second session is still blocked, of course, from the whole transaction, which is isolated, not just the object. So you will see the block process deport also just the last statement of the first transaction, which is the select. Understand this?
So it's the last statement of the.
You always get the last statement. Same in activity monitor, same in any other tool. This is simply the way it works. You see the current statement at the moment of the detection. Because the block can actually happen much later than the original change of data. Let's talk in seconds. Like we have 12.000, like 12 AM. In this moment we have a transaction updating data. Let's say it takes 0 seconds. That's 12.000. So now it's done. Now 3 seconds later, 12.00003, the same session is doing a select from another table. Doesn't do this the first one. Alright, there is no blocking yet, it's just done with the first update. So 3 seconds later. Now we are at 12.00003. Now let's say it's 12.00005. Another transaction comes and wants to read data from the table that the first transaction has updated. Okay, it's being blocked, obviously, because the locks are being held in memory, as we saw in the M2 locks. But unfortunately, now even if we would immediately see the data, like the session information from the first session, we would just see the select, because the update is already gone, it's not the current statement anymore. And even more, we wait 10 seconds. Doesn't matter, we cannot go back in time. So we see what's currently going on, but we cannot see what actually caused the lock. We can see the log, obviously. We can see the X log on the page, on the table. We can figure all that out, but we may have problems to find out what the heck did this guy do before his select. Why did he touch the table? If you don't know the code of the application, there can be a lot of guesswork. In complex environments, you have no clue. The developer may not be reachable. It can tell you, if you have this select, I guess before this select, I always run this update first. You can be lucky, you can also be unlucky. This is one of the major problems that you have in blocking analysis. You cannot go back in time. Once you have the blocking, it may already be too late. It's like 30% of cases. It's like that.
But if the first transaction, first select statement, and the following update has committed, then it doesn't.
If the first session has committed or has not committed?
If the first transaction select and the update has completed,
Let me just put it like this, so maybe to make it clear. We have an update T1 in session 1, and then we have a select T2. Yeah? Something like that. This is the first session, session 1. Now we may have a second session, session 2, which is coming later at this moment, and trying to do a select on T1, and assuming this one is a transaction, and well, this doesn't matter if it's a transaction or not, but this one is a begin transaction, basically. Begin. And it's still not committed. Yeah? It would like to commit somewhere around here, maybe. Yeah? This is the scenario I'm talking about. Then it would happen. Right? It would be blocked. This one would be blocked because of this, but the current statement is already this. So we are like, why the heck is the select being blocked by the select? Yeah. And we figure out from the DMVs maybe, okay, there is a lock on this table, but we still don't know why. And what did he do here?
That's because those two, the update and the selectors, are shown as two separate statements within the same tag.
Exactly. Yeah. Yeah, so I cannot give you a solution except one. You should have the ongoing monitoring tool, but even then, you may not catch it. Yeah. Because you cannot potentially see ahead and say, oh, let's just all catch all statements that potentially lead to this problem. That means basically all statements, yeah. And you certainly don't want to trace every single statement on your server. But if you run into this problem and like after weeks of analyzing, I mean, you try to do that with extend events, with event notification. Once you run certain scenarios, you try to take certain, let's say, you know that the customer is always complaining that he has having this situation, is an unknown food transaction at a certain moment of the day, and you try to trace this whole hour, for example. Hope in this hour you finally find the real fault. Yeah? You can try it. Yeah? For this hour to really trace a lot. Yeah? That's the only way you could really get that. If you can't find it in any other indications.
Am I right in thinking that locks belong to the session and not the statement? That's why you don't know exactly which statement it is within the session that is holding the lock?
That's correct. The lock is just something that's held in memory on account of a session that stores that one, and the statement is not held in memory. It would be helpful, but yeah. Yeah, it's all, like you can run all kinds of tools, but what's SP who's active doing? In the moment that you execute it, it takes the currently executing.
It also shows the back to the next
one.
You can also get the entire statement in front of the story.
Yeah, but if it's the second statement, SP who is active can do no magic. SP who is active can read the currently running statement, cannot go back in time.
Yeah, hopefully it can show you if it's in one big procedure.
If it's a procedure, if you happen to find out that this select belongs to a procedure, then of course it would be wise to take a look at the procedure code and find what's wrong. Okay, yeah, but then we go to who is active also. Yeah, so whatever tool you use, yeah, if you just run the tool in this moment, you will see this and this. Yeah. Whatever name it has, this tool, yeah. They may give you the whole batch, yeah, but if it's a different batch, yeah. But what it does not really save it. It's just to make it easier. So what you can do is use SP who is active or actively to say, oh, probably this happens again in an hour. Yeah, so let's just run it now and keep tracing, and hope we find the same pattern and then find out right. Yeah. So for that you can use DMVs, SP who is active, other tools, whatever. Yeah. But certainly not for the whole day. Okay. Good. There's just some explanation around that. The typical problem that you may encounter. Okay. That was process reports. Yeah. I used to have this funny video here. I don't know. It's not going to work because I don't have sound. So there is not really fun in this one. I don't know. I mean, you see this guy is having pages in his hand. And you see this guy
Like, then given it got that page, that's what he's saying really in English. So that's why I took this video here, I really like it. This is NOLOCK in video. Okay, I give you the page. Just make very clear. I have the page for you, but no matter what, give me that page. That's NOLOCK. Anyway, so because that's the topic here, how can we get around the blocking situation? Those are some methods that you see. NOLOCK/read permitted is really the same as changes of the transaction isolation level for the duration of a statement, for the read statement, for the select statement. Now the problem is the data is not trustworthy in many ways and not just in one way. Probably everybody knows that you can have false or missing updates. Like you read the data before an update is happening, or you read it while it's happening, and maybe somebody is trying to hold it back. So it's not reliable data. That's what everybody knows. But there are also many situations where you can read data not at all, like you're missing data, or you read data twice. And this has impact. I mean, if you're running a report from your sales daily, and you're talking about millions and millions of rows and dollars, and you're missing a couple of thousands, I mean, it just depends on the row. Maybe it was this one sale, this 100,000 that you suddenly read 10 times. Now you have 900,000 more than you clearly have sold. That could happen if you read double data. Missing data, where you're missing this important big sale and not enough money that you report. So, to make it easy, the NOLOCK basically is especially dangerous when you do have a high transaction amount on your table, on your data, which is exactly the case where most people would use it. The more conflicting transactions, the more you tend to, oh man, let's use work and NOLOCK to get around this problem, but in those situations it becomes more dangerous. If the data is not volatile, if nobody is really changing data, then it's pretty safe that you will not get those problems. But then it's also not so useful, right? So that's the trade-off, the big trade-off where I really never recommend it to use it. And if you do, you should really know what could be. I mean, for certain scenarios, it may be okay, but you really have to consider it from the business. Like, is it really okay if I report the wrong amount of data, whatever the data is? All right. Yeah. Obviously, there is a timeout, but you can also check, set it on your own session. So if you want to improve your application, you could put a timeout of like 10 seconds on certain crucial statements to not even bother waiting longer than that time, to have a quicker feedback to the user, please try again later. But watch out, it's normally a rollback. You're doing it, having a timeout in the middle of your transaction, the transaction is still open. So you could cause other problems with that. Another really nice one is the read past hint, but it's only useful in a few situations, like in queuing tables. That would be a perfect example. If you have a big table of rows of like work, and for example, a table where transactions pick out a row and do something with it and then delete it from this table and keep doing it. It doesn't matter in which order. You just have to fill in all the rows here. There's many rows in the table, many transactions. But the order does not matter. You can use this one perfectly. If one row is being locked because somebody is already working on that row, pick the next one that's not locked and move on. So don't waste your time waiting. But if all rows are locked, you won't do any lock. So you have to really know what you're doing. The number of rows that you're skipping will not be feedback.
So in that case, when it skips it, does it go back later if it becomes released?
No, it's just one select statement. Either you get the data or it jumps over and keeps reading until it's the first gap there between the locks. And if there's everything locked, then nothing there. Sorry about it. So you will have a false feeling like, oh man, there's almost nothing in the table. Whereas maybe they're just locked those rows, those many rows. So it's only for certain scenarios, not for the typical use case. Alright.
let me show this problem with NOLOCK, because I think this is the most interesting one. So I do have a table with 30,000 rows in it, in this database, and I have 2 sessions. Now this is going to be session number 2. This session will read the data. The amount of data that it's reading will be selected, and we will have a list in a moment. It's reading for a couple of 30 seconds. There's multiple delays here. This is 3 milliseconds. No, it's waiting for differences. So this will not give me any data right now, but basically it would give me the 30,000 rows. Now, 10 times. Now this session, why it's a complicated code, basically it's going to only report the amount of rows read when it has found 10 times a different row number than 30,000. That's how this session works here. Now the first one is going to cause this issue. So we have a situation now that one table is being updated constantly, and another station is trying to read from this table. Now we just see what happens under read uncommitted NOLOCK. Now this is session number 2. So I need to be a little bit fast. So start and alright. Now let's just see how long it takes until he has turned out. That was quick. Okay. 6 seconds. So within 6 seconds of keeping to select data, and it's still updating in the background, but now we don't care. 10 times it found a number of rows which is not 30,000. You know, I mean, it was an update statement. I did not change the number of rows. I did not delete. I did not insert. So, what the heck? You may think. Yeah? So sometimes 25 rows off, 65 less, or 42 more rows. So it means basically double reads, triple reads, whatever amount of data has been read twice, or did not find the data. Yeah? This is what I mean by missing or double reads and the danger of NOLOCK. This one here. Yeah, the non-committed everybody knows, but those are the ones that I'm more afraid of. Yeah. Okay. Yeah, so the more concurrent updates, the more this will happen. Yeah. This is the general rule. Anybody know why? Patrick? Data movement, right. The reason behind it is the data movement, because when you update data or into the update, yeah, you're reading your first session or second, whichever, that is reading is basically scanning from beginning to end. Let's just imagine one clear scan. Yeah. But in the midst, somebody's updating, so let's say the timeline from here to here, which might be the table. Yeah, so maybe here is a row, and just before he's gonna catch this row is being updated, and by the order of the index, put somewhere here. Yeah. So it keeps reading, but now it would catch that row. Unfortunately, it's being updated again. Put here, or back, or whatever. Yeah, and keeps reading, never sees this row. It was the same image when you would say like, okay. Here's a data row, we just read it, somebody updates it, while you're still reading, update, moves it here, and you're reading it twice. Same concept. So the more of this action you have on the table, the more prone you are to run those situations. That's the reason. Okay, and what's the easiest way to group to have fragmentation on your table? Yeah, that's basically the concept that I use. I have fragmentation. Has nothing to do with the topic of this talk, I know, just a reminder everybody, it's easy, if you want to fragment your table, just use unique identifier. Makes such demos easy. Alright. Good. So, here, we saw that. That's good. Yeah.
So, the best option to really get rid of the blocking situation, not of the lock will be there. To change data, okay, get rid of the statement and change the data, but before we need it. So to get around the blocking, you can also use indexing, and this is a very good way to do because it's usually also faster. So let me give you an example how this would look. I have, this data is, this one, try to check, here it is, okay. So there's still a blocking situation, poor guy, kill him. Bye-bye. Index versus blocking. So we have one session that is going to do this. We can already start it. So this session is doing an update on a certain product ID 907, and a second session. Open the window and the window here. Second session, we are going to do a select from the table, and we will be blocked at a certain point in time. Now we keep running, and this is not because the table is so big, it's because there is a lock on one row at least. If we use our watcher session again, just have to use the right database name now. Now we see reading here, there is again a key lock. The table intent exclusive. This is not a problem again. IS and IX, they don't have a problem with each other. It's just this S1 cannot get there. This is why we are waiting here. Alright, so this does not really work. Now, this is really bad code, as we all know, select star, you cannot optimize very well. So, it would be better to write the code like this. Like, how about you make your mind up what you really need? Let's say we just need those products. Now, we are still being blocked, but now we have a chance to improve it. Now, you will see the same kind of blocks here. Object products, shared docs, same team. Didn't change anything so far, but now we go there and change things. Now, I'm going to go to session number 1. This one. Obviously, I first have to roll back before I can do any changes here, or commit, whatever. And we will do what any good developer does, create some useful indexes. So since we have made up which columns we need in the session number 2, we're deciding to create an index on product ID, always good, and include just those columns that the select query is using. We found out that this would be a good index. F5. Now we have the index, and now we will start the same situation again. The same product is going to be updated again. We did not update, we rolled it back before. F5. And the session number 2. Now coming with the stupid select star. Will still be blocked, obviously, but I mean we changed it, so we will not use the select star. Database anyway. We're going to use the efficient select useful columns query, and bang, it's finished. No blocking situation. Now obviously we just use an index for that, and the index is not the object that's being blocked. It's the another page. So we know it from now. I mean the log is still there. Just have to look here. The watcher session. It's open, the log is there, but there is no conflicting access. There's something else in the background. I think we can ignore that. a column involved, I don't know. But yeah, so we have still the IX there, but it's a key on a certain index. Let me actually check which one. Probably is the cluster index. If we go to the session number 1, to the session number 2, bye-bye. And session number 1, what is it actually doing? Like which, where is the data coming from? And just start this again with the execution plan. Turn on. And yeah, it's just a clustered index. But since we are updating a row, a column that is not included in the non-clustered index, we don't need to care about this block. If you write efficiently. Now there's two things you need to do. You need to write the select efficiently, like only use the columns that you really need, and also the updates. Sometimes you see applications doing this catch-all update, yeah? Or there may be many fields in the application, maybe you just changed one. Anyway, let's just have one procedure that re-updates all fields in the table, even if they have not been touched. That would destroy this concept totally, because then all indexes would be updated, everywhere would be locked. So, again, it's a question of design that helps you to avoid blocking situations. Very important and much more efficient than anything else that you can do. And safe, you have nothing to do with dirty reads or whatever. Yeah, okay. There's so much about the basics. Now, Lock-Escalation we have tangled a little bit, so let's talk about this a little bit. Lock-Escalation is a concept that is put in the engine because of costing. Because all locks cost. They cost CPU, also memory, and it takes again time to just figure out if they're wrong or not. So it's a little bit like a curve here. The less granular your blocking and your locks are, so the whole table is very easy to lock, just one lock on table level, versus many rows, is a high cost. The cost is here, sorry, and here's the granularity. So the cost on many rows is obviously much higher than if you just block the whole table. So imagine a scenario, you have a 100,000 rows table and somebody is updating 50,000 rows. Would you rather have 50,000 locks, single locks per row, or just have one table lock? Quite obvious the answer that it's way more efficient for SQL Server to just place locks one time instead of 50,000 times. If you open the DMV with so many blocks, you will also see, it takes a while, just to read the blocks from memory. And obviously SQL Server has to do the same stuff when he's trying to figure out some of the other statements who want to read the data, and has to figure out, is your lock conflicting, or is your read request conflicting with any one out of those 50,000 blocks? It takes time. I mean, memory access is fast, but it's not infinite fast. So, this is the reason why the concept of Lock-Escalation is implemented in SQL Server, and you will read statements like, whenever SQL Server holds more than 50,000 locks on an object, he will do that. He will do what? He will take the 50,000 lock or 5,000 locks, eliminate them, and instead put one lock on the whole table. That's the way it works. So the concept is here. Instead of 50,000 row or key locks, or 5,000 locks, put one lock on the table. So it will actually first have the locks on the lower level. It's not going to be like, oh man, there's so many updates coming towards me, let's just lock the table. No, it will be like, okay, updates coming, and oh shoot, I already have 5,000 of the locks here. Let me try to convert it to escalate it to table level. That's what he will do. So if he fails, if he cannot escalate to table level, the locks will stay around, the 5,000 locks. I mean, they need to be. So, and then it will try again if there's another new 1,550, 2,050 locks. In theory. Now, in practice, I don't see anybody's ever seen the 5,000 as a threshold. The minimum amount of rows that I've ever seen for lock escalation is like 6,000. So you can safely assume at 5,000 you will not see lock escalation. Forget it. And if you do, please send me a picture. They have to be included. I bet you will never see it at 5,000 rows. Maybe 6,000. But it's not really so important because usually it's about the masses of data. Don't get all hooked up on the 5,000, 6,000. This should not be so important. If you're talking about 10,000, you can be for sure. If it's 10,000 rows, you don't get escalation. Something is off. Now there are what can be off. Why can it not? Why could it be? Maybe it's just too early, or maybe just tried and it's still trying to. Okay, yeah, could be. But of course, imagine a table of 500,000 rows and there's 10,000 blocks. I mean, maybe there's another session who's updating just one row somewhere else on the table, and it was there first. We cannot just escalate our 5,000 or 10,000 row logs to the whole table when there's still some other session. And in the environment with many users, this is very common. Yeah, that you have here and there blocks on the table, already blocks on the table. So this is why you keep trying every so often. Yeah? So it does not happen all the time.
That the escalation happens at the beginning of the statement, like is it based on the estimation?
It's trying
based on the estimation
of statement at the end, like update where date is like equals so and so, and it happens it's like touching 10,000 rows, and SQL Server is monitoring the amount of logs happening. One after another is coming, and when you see, oh, 5,000 reached already, he tries to escalate. So it's in the middle of the statement. It's not going to wait until it's finished the statement. If it's in the midst, you would also do it. If it takes a long time, you will already have tried it. To speed it up. Let's say your statement is touching 100,000 rows, and the statement takes 10 seconds. If you're lucky, you already was able to escalate after the first 6,000 rows after half a second. And then, of course, it will be faster, because now the rest of the, what did I say, 100,000 rows, I forgot. The rest, many rows, will not need to place a single log for each row again. So it speeds up the rest of the rows by far. I mean, Lock-Escalation is definitely a performance boost for the update session. In the data warehouse load, for example. When you're loading hundreds of thousands of rows, you are happy if you get escalation because you don't need hundreds of thousands of logs to manage. SQL Server doesn't need to do that. So you will just lock a table and now everything is faster. And also with that, you even get the minimal logging exclusive log as a requirement. I mean, there's certain scenarios, but there's one of the requirements can be that your whole table is just locked by your transaction. So you have two benefits. You have less locking, just that one log, and you also have the minimal logging on the transaction log as a second benefit. And of course, the second one is even better than the first one. Place together. Okay, so this is the one depending on your load on your transaction. Now, if you see those, you have a bigger problem. You have a real problem. So if SQL Server is using 60% or its whole of its buffer pool just to manage logs, then you must be talking about millions of logs on your server. And as you hopefully by now realize, locking is not for free. Even if there are no blocks, just the locking is already cost intensive. So if you use so much space, you just keep a list of all those logs in your server, it will also try to escalate all those logs that it exists to a higher level. Just here and there, not depending on transaction. Just picks the logs and tries to escalate to gain back memory. Now this means you already have definitely a problem, and you will feel that if you run this situation. Okay. You can also disable it, change it a little bit. Sometimes, in certain scenarios, you may want to do it. In data warehouse load scenarios, if you have conflicting situations, sometimes it can really be annoying. But I would not recommend it because this is on the whole server level. I would not recommend this to do it so easily, so quickly. Because it's, the concept itself is meant to save memory. So it can run into other problems. Okay. I don't know, how much time do I have before again? till midnight. Or people late. You want to see something on Lock-Escalation? Okay. A few lots, so see this one. Now I have a table here. But actually, let me do this in the VM, because here I have the trace, and the trace is also tracing Lock-Escalation, if you remember. This was one of the events that I had in my trace, so you can see it immediately. Or should I do? Alright. Now, I have one transaction. This is obvious. I mean, it cannot be single statements that are doing few rows only. Now, I need one transaction. And the table is basically ordered by ID. So when I say ID equals less than 100, it also means I'm touching 100 rows. Yeah? Just to make it easy to understand. So if I run this statement, I will expect to have 100 row logs plus a few page logs and one object log. Yeah, so let's see. Okay, key logs, and just by the count of it, 105. Yeah, that's the 100 rows plus 4 pages, I would bet. Okay, makes sense so far. Good, that's 100 logs. Now, let's increase it to just to 5,000 actually. So this is the 5,000, the documented limit. If I now run again, the check query, we have 5,194 logs somewhere. But of course, they need to be the same level, so we need 5,000 key logs. But yeah, you can be sure it's 5,000 key logs minus those page logs. Because this is how I built the table. Okay. Now, well, obviously, Lock-Escalation didn't happen at 5,000, otherwise there would be just one log. So 5,000 is obviously not happening. Now, let's go to 6,000. That's what I said, right? Like from 6,000, you may see it in reality. Let's see if I do. Now, there are 6,000 plus logs, yeah, key logs and page logs. Obviously, no escalation, I mean nothing magic here. So maybe I talk bullshit. But we can give another attempt. So now we should really see, right? So let's run this again, and just by the time it takes, realize I mean there's still lots of logs, yeah. So no escalation. Alright, what am I? Is it the way you would expect, or what do you think? Am I just a big failure? Any ideas?
Maybe because nothing else is trying to access it. It's not causing any blocking.
Yeah, but we're not asking for blocking. Because it could still cause memory constraints. So the only rule is we had 7,000, but
I was going to say you got to trace those trace flags on.
no, by default it will happen, but not like this. So if you read again, the should always read, yeah, what's documented. How many statements did I run? A couple of them, right? First statement 100, then 1,000, then another 1,000, but the new logs were no more than 2,000 because I just kept adding a few more logs. I mean, I updated the same rows, so there's no new log. So every statement was not more than 2,000. Okay, I should have read that. So obviously, this is not the way I would ever get to escalation. It's already interesting for you to know as a developer. If you want to avoid escalation, just stay below the 5 or the 6,000 just, yeah, and you will not never see it. Yeah? Easier than just working on this phrase gadget. Yeah? That will also not have if you don't want escalation. Yeah? There can be reasons where you want to avoid it. So, okay, this was bullshit. Yeah. Let's do it the right way. Let's go up again, and I will begin the transaction, yes, just so we have time enough to see it. But I will go right away to the last statement, in one statement. Now, if we first check the watcher session, it should be nothing here right now, right? Now I run a statement with potentially 7,000 locks that need to occur, and there it is. But just magically the background was fast enough, and if I now check my session in the background, I am expecting to see the lock escalation. Here it is. Lock threshold was the reason, and we escalated at 6,249 rows. Yeah. This is very important to see. As I explained, it's happening during the statement. I cannot be so fast. Yeah, I mean, I logged 7,000 rows, and I like half a second later I selected the watcher session. I never got to see those 7,000 or 6,000 row logs. If I would have monitored each log, I would have seen 6,200 for a very short moment, but then we replaced with the single statement. And the other rows that are missing, I mean there's a difference between those rows and the 7,000, they did not need to ask for logs anymore. Yeah? They already could jump into the tables or log for me, just my table, thank you. Yeah? This is how it works. Very cool. Yeah, okay. So this is the built-in version. Now there's one way as a compromise that you should know as a developer. Because again, a log escalation can be good, can also be a little bit too much. Imagine a table with 50 million of rows, and you are escalating for the whole table is blocked because somebody happens to update 7,000 rows. What's 7,000 rows in a table of 50 million? Nothing. Yeah, so this feature basically is coming from like decades ago, where those amounts of data didn't exist. Yeah, nobody really thought about it. So what can you do? Yeah, I mean, you only have the option so far to not allow escalation, but then you would still have a case of somebody's updating 100,000 of rows, and this is a lot of logs, which would we have to manage versus the whole table. Now we don't want the whole table, but we would like something like maybe part of the table. Huh? So think about partitioning. I mean, if you have such a big table, you should think about partitioning. Because then you can work with partition borders to say only escalate is in one partition, but the whole partition, not part of partition. But at least there we have some logic. So if we happen to have a table that has those borders here, 50,000, 30,000, 10,000, 20,000, and so on. So each 10,000, each bucket of 10,000 gets its own partition. This is the partition function. Now, obviously, this is not a case of I want to optimize IO subsystem. Yeah? I just put everything to the same file. Yeah? This is not what I'm talking about. I'm talking about optimizing for locking situation. Yeah? So I put everything in the same file, but I just have the logic prepared. Put my index on the partition schema basically here, and that's it. And if I just look at the table distribution now, I should see how much data I have in each partition. Now I have about 10,000 rows in each partition except the last one. Yeah. And now the idea would be, if I update up to 5,000, 6,000, 7,000 rows, I do want this to be efficient. Yeah, I want an escalation. I want one lock for that, one single lock for those 7,000. But I still want other users to be able to work on other areas of the table. So I want a lock on number 4, for example. Yeah? One lock for one area. It's going to block 1/5 of the table in that case. But still, some people could work for the older years or whatever. Yeah? Whatever the scenario is. Now, to make it short, there is one thing you need to do. Like, if you don't do anything else than I just did, nothing will change. It will still lock the whole table. It will escalate the table level. It will not by default jump to partition just because there is a partition there. What you need to do is, you can read it here, the default partitioning Lock-Escalation, the default Lock-Escalation level is on table. This is the reason why you always jump to table, even if you have partition. You need to change this to Lock-Escalation equals follow on this table. And now you will see on this table, not the table option anymore, we have auto, and now it would decide what's best. It would decide, oh yeah, I can use partition level, or no, it's already so many, touching so many partitions that I still need to lock the whole table. What's possible?
Is there any disadvantage to have that on auto all the time?
Good question. Yes, because once you have this, let's just mention back this picture of the partitions. It makes it easier to understand. The reason once you have this setting on, and you do have then certain locks here or there on our own partition, the potential for deadlock is increasing. And if you just turn it on and don't tell anybody about it, and then some people may be like, oh, it's not happening, we have deadlocks that we have never seen before on partition level. Can happen that you have a conflict there that it turns to a deadlock. This is the reason why it's not automatic. We have a higher potential for a deadlock than we had before. Yeah, okay, that would be Lock-Escalation. Okay, yeah. Are you all familiar with deadlocks? So maybe we don't need to talk about this too much. Let's do some update on that. What I would ask you to do, please forget all those old trace flags. If you're not already familiar with extended events, please start using it. Forget profiler, even forget those old trace flags. They are very pretty to read. Yeah, and if you ever need to troubleshoot using those trace flags, have fun. Yeah. Make your life easier. Use the built-in system health event set, the extended event setting. Who knows that one? Okay, so maybe I do show this one. Not a big demo. This is what you would get if you have this deadlock trace flag. Yeah, fun analyzing. Now, since SQL Server 2008, you do have in every SQL Server here on the left side the system health event set. Now in 2008 you didn't see it because there was no rule support, but it was still there. And if I go in the session, and if I actually did have deadlocks on this system, and I'm pretty sure I did, now I see a lot of information here, but what I really am interested in is the deadlock, so let me put a filter. Something here. Out. Now I can filter this trace file here and put a filter on the name, the event name, because I know the deadlock event is called XML deadlock something. Yeah. So we are looking for something that starts with XML, like XML dead. Somehow I like this abbreviation, don't you also? Alright, that is XML deadlock report. Click here, click there, what do you need to click there? You can also click here, and you get a graphical representation, just like in the old profile days. So this is the deadlock report that is being passed here in SSMS. What getting a little bit bigger here?
How far does it store this deadlock information?
Just in general, all this information here is stored as long as the targets hold data, and you can see it here. So we have two targets. The ring buffer is obviously very small, 4 megabytes, so we empty very quickly. But the event file is 5 megabytes times 5 files altogether. And typically in a well-tuned or averagely tuned system, you can go back like 4 days. If you only can see like 1 day backwards in this file, you're pretty sure already have problems, because it means you have a lot of errors in this file, a lot of bad situations. It's catching lots of different information, not just deadlocks. Deadlocks are of course very big. Yeah, so the less data backwards, that means it's filling up very quickly. Yeah? But you can increase the size. Yeah? This is supported. Just don't change the rest of the definition.
With those two files, is it safe to assume that the ring buffer and the event file will contain the same stuff?
Yes, they contain the same stuff. It's just the ring buffer is going to be overwritten much quicker than the file now. Okay, so much about deadlocks. So you will have it here. And I think it was the second event, and then you can analyze the XML code here. The graph is nice for demos, but sometimes you will need to see the details. It's XML, so you could put it in a table and parse it from there, like the block process report. So. Actually, I did build a tool once to parse the data there into a columnar format, but I honestly never got the time to keep updating it. It should still work, but I don't have to. The code is out. You can see the code there to make it better. Code for the current releases, but you can also just write more stuff. It's not really hard to parse. Alright. Yeah, so deadlocks get detected every 5 seconds, which had to do with the deadlock, with the block process report as well. That's the one thing. Yeah, and once it finds a deadlock, it will keep looking quicker, so it can look as quickly as 100 milliseconds. Like if it sees a deadlock immediately after the first one, it will then check even quicker again, so it will not wait 5 seconds. This is one that's neat. Until we go back to the normal things. Alright, so if I avoid deadlocks, isolation level is one thing. I mean, if you change the isolation level, you have less blocking, because they will be ignored. It's possible, although I would not really do it. What the general rule is just try to make sure that if code is accessing the same object, try to implement rules. Like if you're like put it somewhere on a document, if you ever have a transaction that's touching the orders table and the order details, first go to orders, then order details. Maybe the rule, like the order of things for scenarios. That will avoid many deadlocks, because deadlocks occur when you have different order of accessing the same object. So if you can prevent many of those cases, you get rid of many deadlocks. But you will never get rid of all of them. It can still happen. So you still should account, as you saw, you can avoid a block is indexed, but obviously you also would avoid a deadlock situation if you don't even run into a block. Same thing. Actually, even the index optimization advisor, this tool, is pretty smart. If you store it in a file containing deadlocks or deadlock situations, it can figure that out and also advise indexes to avoid those deadlock situations. Pretty cool. It just does it. Not really a documented feature in itself, but it's really smart enough to figure out how to avoid those blocking situations. Another thing that you see sometimes, mostly it's a little bit more codey, early locking. This is where you have the update lock. If you cannot avoid that certain procedures are working in different order on objects, how about you put the lock on the second table already from the very beginning? So basically faking the order of things. You keep the order of the block on the second table already from the very beginning with an artificial update lock, and then block from table 1 and then to table 2. If now another transaction comes that would first like to get to table 2, it's already blocked out because we had this early update lock that we put there. This is the next statement artificially. That's a multi-trick sometimes. Okay. Now, last one and theoretical topic would be, has anybody of you already looked with other isolations level, snapshot isolation? Yeah? No. So you have those two flavors, you have snapshot isolation, you have recommitted snapshot isolation. Those make it very convenient for you to have reports or defaulting workloads without being blocked because they work on the old versions of the data. Yeah? So simply ignore whatever is being locked because you are not even looking at it. Yeah? So of course you will also not have a deadlock there. Yeah? No block, no deadlock. That's an interesting concept that you should really look at if you have a typical scenario of many reports versus the same tables against the same tables where you have transactions. Yeah? So think about maybe you can use recommitted snapshot isolation or even the complete snapshot isolation. With a sort of overhead, obviously, nothing is for free. Yeah? That would be strange. It puts the version into 10 and increases your row sizes slightly, and also the chances for fragmentation. Okay, now so you have to account for that, keep monitoring that your access to temp database is fast enough, that you handle your defragmentation accordingly, but then it's really a good alternative. A completely different one would be this one.
Do you see many people using recommitted snapshot isolation or snapshot isolation?
Pardon?
Do you see many people using either of those?
Not many, but I do see people.
What about readable secondaries on...
Readable secondary is based on the same principle, yeah, good point. Yeah, so the readable secondary is using RCSI, I believe. So we have the same, like, availability group is the secondary to be is read enabled. You can read the data from there, and it will give you the version for the primary that has been active before the update, whatever is happening. And also in this case, the version will be 10 dB, but the 10 dB of the secondary, not of the primary. It's a bit confusing, because of the secondary it's enabled. Just under the hoods, you don't really see it. You read the data and you get some raw, but it's not really the current raw. It's not uncommitted. It's the version from 10 dB in case there is a version. If nobody changes, you just get the current raw. But in case there is an update, you get the old version. So that's based on snapshot isolation, which also has the same effect in the primary because it does increase the row size of the primary, even though you don't have the snapshot isolation of the primary, but you have it on the secondary. The secondary has the same database, so it needs to have the effect in the primary. Now, so you have to monitor it. Yeah, I'm not going to have a demo here. I think we're running out of time, but feel free to ask questions. One other thing I would like to mention, because I'm really a fan of this new technology. Has anybody ever used In-Memory OLTP? Excellent. In production or testing? Testing still. Okay. So In-Memory OLTP is new technology that came into SQL Server 2014. It's basically a completely new storage engine, in SQL Server with its own concurrency control. So the concurrency control, which we know before, was all based on this read committed, read uncommitted, repeatable read, etc., using locking or using those new versions of snapshot isolation or read committed snapshot isolation versus 10 dB. This is the old version. This storage engine, which is inside SQL Server, so basically the second storage engine inside SQL Server, is using a different concept. It's not storing snapshots of data in 10 dB, that would be slow, but in memory itself. That's why it's called In-Memory OLTP. That's what also makes it fast. So the concept here is don't use any locks, and of course no blocks, no lock, no block. Always work on versions of data. And the version is stored right next to the raw in memory, so there is no I/O necessary for an access to the version, and that makes it very fast in such concurrency situations. Now, of course, it's not just easy to change your table, I know that, but at least I would like to point it out that if you have a high transaction table and you are able to rewrite your code, if you say the situation, okay, it's so bad, the performance, you already tried everything, you tuned already indexing, etc., everything else, you should really have done that. It's not the first step. But if you have everything, if you have done everything right, schema is perfect already, then this can be the next step of evolution to speeden it up even further. Now, the memory engine has less I/O. It does have I/O, ironically. I mean, you want to have the durability of ACID, right? It would be nice to have the data after restart. Yeah. You have the concurrency control, the C. You have the isolation, and your durability. Oh, and the A is atomicity. So you have all those features, but working in memory, way faster. So no locks and also no ledges, because they have different storage engine. It doesn't need those things. It just uses the old version from memory based on a timestamp to go back in time, pick you the right matching version. Yeah. Yeah. What you have there is actually just 3 isolation levels. So we have 8 isolation levels with the same names, but they behave differently because they are now using optimistic versus pessimistic concurrency control. Optimistic uses no locks, and pessimistic is using locking. This is where the term comes from. So the optimistic version of those isolation levels is based on this memory functionality. You have snapshot isolation, you have repeatability, and you have serializable, but you do not have recommitted. That's something you need to watch out if you develop. Very confusing, yeah? Recommitted would give you and would make you wait until the commit. Right? This is how it's implemented in pessimistic isolation. But here, we don't have this. We don't have a, even if we wanted to, we cannot block you in memory OLTP. So we will always give you the whole snapshot. That's the lowest isolation level. Different approach. Yeah.
So in the previous case where when we have a diagram with the select transaction 2 happening, so you start the new transaction, you will select, do an update, and then the select 2 transaction starts. So in that case, will it read the old version?
It will give you the data as it existed even before the first transaction ever got to change it.
So it gives you the prior committed version.
It gives you a consistent version from before something changed that has not been committed yet. Or that would be inconsistent. You don't use being uncommitted. That would be the inconsistent way.
Yeah. The other question I have is, when you have column store indices, does that use this technology?
Now, since 2017, you can combine column store indexes with in-memory OLTP, and then it's not using this, and they kind of live together. So the hot data is just in memory, like the freshest data, but then you can configure this. The older parts will be in column store for bigger queries. So column store is efficient if you make a big select from the table group by whatever, like 1,000 of rows. But in parallel to that, you still have the in-memory table, which is efficient for single row access, or single update or select. When you combine those technology, you have both memory engines actually at the same time working on the same data. Very cool. If you think about it, you have two storage engines working with the same data. Very cool that they even got this to work. And consistently. If you look at Oracle or SAP, they use this technology basically also, but they have it like a caching layer up front, so there is it's async. It's like seconds behind the column store index versus the memory engine. But not the SQL Server. You don't need to care about which index you are asking, you will get the point in time that you're asking. So they work together in a way more like complementing each other. But it's only 2017. Before that, we could not combine. Before that, either the memory optimized table or the column store. Column store is for big queries, large batches. In memory is for small, quick transactions. Always keep this in mind.
I was just thinking out loud that this technology, it seems to feel, I'm just trying to think, it should apply to any data structure that's in memory. It seems to be, what you're saying, is it's only applying to certain tables in memory, not, like, why wouldn't they use the same thing on column store?
Which part of it?
Optimistic version.
I have a little bit. Yeah. Some of the stuff I learned from this is latch-free, lock-free.
Absolutely, yeah. But the thing is, if you use this memory table with a big, large request, select, give me everything from the memory table, it will be very inefficient. So it's really not, it doesn't really make sense to use the same thing for column. I mean, it's really two different works. Column store is based on compression.
Yeah.
Yeah, it's compressing the data. This one is not compressing at all. The only speed factor is it comes everything from memory, and we are super fast because we're talking about single rows here and there with the hash table. Everything fine. As soon as we make it, give me 10,000 of rows from memory, this will be very slow, even in memory. Yeah? This is not as efficient as columns, because columns, the data will sit aside next to it in compressed form. That decompress and gives it, and it's also, I mean, talking about millions of rows of column store. That's when it gets really efficient. Before that, doesn't really work. Yeah. So it really cannot be replaced. But of course, it's interesting that they even got it to block on the same data, because of course you can have millions of rows in memory, but you're blocking live only on the last couple of thousand rows, and it makes sense to combine it. Yeah. That you don't need to think about the old data, the cold data. So SQL Server is handling that. That's the idea. Yeah. It's big, it's memory, but
the column store also works in batches of 1 million rows. Yeah. So it grabs 1 million rows and then compresses them and puts them into a segment. So it's more for analytics and scanning and pulling out.
Column store for inserting an update, for example, doesn't work. I mean, it does kind of work in 2016, I think it started. But it's faking. The column store index will never be changed in place. It's not possible because it's compressed. You cannot live update compressed row in the column store. So it's using an external row store table. It gives it a feeling like you're updating it, so it combines it, but it's not really good. This one is good for updating in place. Column store is not at all. Okay, I know I talked a lot. You will get the slides, so you can read through some of the stuff that I have not talked enough. Yeah, thank you very much. If you are like me, it's like to save time. As you can see, I speed up here a lot. I like to use tools that help me. This is the one that I would like to point out. SQL Server monitoring tool. If you can afford it, if your customer can afford it, get it something useful. There's other tools also where they do similar representation of data. I just happen to like this one because you can do very quick and efficient drill down from server level base steps to, oh, is there actually blocking or not? It's not just focus on one problem. Yeah, that's about it. Thank you very much. Questions I think also afterwards.